F of x equal to f of c does not always work, and this only works if this function f is a continuous function. So if the function is not continuous, then the limit exists only if the left limit, which is as x approach c from the negative side, which means if you evaluate f of x at points like this, which is converging, these points are approaching c from the left. So if this left limit is equal to the right limit, which means these points from the right hand side of this C converges to the same point, say L, then the limit is equal to L. So the graphical example would be something like this. So if a function goes up and stop at here and takes a value as C, which this point would be C, and it goes off on the right hand side starting from a different point, then this point on the top would be, this point here would be the left limit, and this point here would be the right limit, and this point would be just f of c. So these 3 points are different, so the limit does not exist. So if the left limit and right limit are the same, then the limit exists, but that limit does not necessarily equal to f of c. So so for example, if we have this function and it goes down like this, but this point is defined here, then what the limit is this thing. This is the limit, but limit does not necessarily equal to f of c. So if you want a concrete example of a function, then this function here would work. So if you take the left limit, then know that on the top is just x plus 2 and x minus 2. But when x is equal to 2, you cannot cancel the top and bottom because both of them are 0, so you cannot cancel it. But whenever x is not 2, then you can actually cancel these two. So there's only x plus 2 left. So if you are approaching from the left, since x is never equal to 2, so x minus 2 is never 0. So anything in the form x approach to 2 plus has x not equal to 2. So that's why you can cancel the x minus 2 here, so that you are only left with x plus 2. So the left limit is 4. Similarly, the right limit is 4 as well, because when x is approaching 2 from the negative side, it is never equal to 2 again. So it's never 0, so you can cancel the top and bottom, that factor, and you are only left with x plus 2. So it's 4 again. So the limit is equal to 4, but f of 2 obviously is not equal to 4. It's 0 over 0, which means it's undefined. And another example would be the Heaviside function. So a Heaviside function is a piecewisely defined function. So Heaviside of x basically means when x is greater than 0, this function is equal to 1. So when x is greater than 0, y is equal to 1. When x is smaller than 0, y is equal to 0. So if you draw a diagram, it's something like this. It's always 0, and it jumps to 1 here. So the left limit is 0, obviously. So if you're approaching this 0 from the left, then it ends up at this empty point, which is 0. And if you're approaching from the right, then you end up at this point, which is 1. And they are not equal, so the limit does not exist. And by the way, to draw a diagram of the function here, so about this function, if you want to draw a diagram, then I think it will be the line x plus 2, but this point is empty because it does not exist, so it's basically a line with an empty point. So the limit exists here, but the function is not defined here.